When the leaves of the electroscope repel and move far apart from each other, there's a charge present. It could be either positive or negative. To find out what the charge is, you can take an object that has a known charge, either positive or negative, place it near the top of the scope, and watch what happens. For example, if you take a positively charged object, you move it near the electroscope, and the leaves move apart. Well, what's happening there? More positive charge is being pushed down from the top of the scope into the leaves, so they move further apart. That seems to indicate that the existing charge is positive, and there you go. If the leaves are moved closer together, that means if they had a negative charge, you're pushing more positive charge down there. That'll make it less negative. There'll be a less force between the leaves. And yes, that's true. And then you can likewise see if the object has a negative charge, the electroscope leaves move further apart. You would imagine that the electroscope would be charged negatively. And then, of course, the opposite, if they move closer, there was a positive charge. Earlier it was mentioned that electroscope can be used to find both the type of charge on an object and also the magnitude of it. Intuitively, it would seem that the further apart the leaves move, the greater the magnitude or size of the charge present. If it was a tiny charge, the leaves wouldn't move very far at all. If it was a large charge, you would see them move quite dramatically. And hopefully, if you've already done this demonstration, you've seen that effect. So that's true. The next section will talk about the force due to electric charges. This is the charge that has the leaves moving against the forces of gravity, which are trying to hold them down, and the tension in the leaves that's trying to hold them in position.